The next part we are going to work on will be the snake graphic. And this one is going to involve quite a bit more. But by the end, we are going to have something like this. And that really makes the game look so much better. Now, to understand how all of this is going to work, let's talk about some logic. The most basic concept you have to understand is that we always look at the relations between the different parts of the body, or the blocks, or whatever you want to call it. Imagine our snake looks something like this. We have the head, we have the body, and we have the tail. What is really important to understand at this point is that the head is to the right of the body, and the body is below the tail. Because of this relationship, we know that the head is supposed to face this way, the body is supposed to look like this, and the tail is supposed to be like this. And that is what we are going to implement. Let's jump right in. Back in the code, I want to look at the snake. At the moment, our draw method is fairly simple. We simply look at all of the points of the body, we are creating a rectangle from that, and then we are drawing a rectangle for all of these points. That's kind of it, and well, that's not what we want to do anymore. Instead, to organize all of this, I want to create another attribute right below the body. Let's call it self.drawData. This, for now, is going to be a list without any values. But later on, we are going to add tuples to it that are going to contain a surface and a rectangle. Surface is going to be the surface we want to display, and those would be the individual parts of the snake. And the rectangle would be the position. Although all of that comes later, because first of all, we have to solve another issue. And that is, let me show the graphics folder. Here we are, and we want to look at graphics and snake. In there, we have lots of graphics. Now, we could import all of them manually, but that would be quite extensive. So there are 14 files in total. Importing them manually just wouldn't be feasible. So we are going to write a dedicated function for that to just import all of the files from this folder. All of that will be stored inside of a separate attribute. Let's call it self.serves. The value we are getting from self.import_serves. This has to be a dedicated method, import serves, and we are not going to need any custom parameters. Basically, what I want to do for this one is create a surface dictionary. Let's call it surfdict. This dictionary is going to have the file name as the key and the surface as the value. If I open the folder again, the first item for the key would be body_BL, short for bottom left. And the value for this dictionary would then be the image itself. And this we are going to do for all of these files. For that, we have to figure out how to go through a folder via Python. And Python has a dedicated module for that. I want from OS import walk. OS gives you system functionalities, and walk lets you walk through a folder. The way this one works is you basically always use it inside of a for loop. For now, let's say for data in walk, and then we need a file path, which we are going to create via the join method, so it works on all operating systems. Once again, we want to go up one folder, then we want to go to graphics, and finally there's a folder called snake. If I open the project folder again, we are currently inside of the code folder, in snake to be a bit more specific. We want to go up one folder, then to graphics, and then to snake. And there we have all of the data. And for now, let's simply print what we get from that data. To make sure we're not getting an error, let me get rid of the example values in the dictionary. And now, if I run main.py, we are getting some values. Basically, we have a tuple with 3 items. The first one is the folder name, so graphics and snake. Then we have an empty list, and this one would contain a name of all of the subfolders. Since this folder doesn't have any subfolders, we can just ignore it. Finally, we have a list with all of the file names inside of this folder, all of which are PNG files. And these we want to import. Although I do have to be specific here, these are just names of the file. We don't have any actual surfaces or images, we just have names. But those we can use for imports. First of all, I want to unpack the data right away in the for loop. We are starting with a folder path. Then we have sub, folders, and finally we have the image names. With that, we get access to the parts of the tuple we get right away. Although we could refine this a bit, since we don't care about subfolders, I'm going to replace this with an underscore, thereby indicating that we are just going to ignore the value. Now that we have that, we want to look at all of the images inside of image names. Remember, right now, this is a list with multiple values, which we can all access via another for loop. Let's call it for image underscore name in image names. Now that we have that, let me print the image name to see what we get. And if I run the game, we have all of the files inside of that list. Perfect. What we can now do with all of that is create a full path. Via this full path on the next line, we are then going to create the import. First of all, though, we have to use the join method and merge the folder path with the image name. In case it's confusing, we are getting the folder path from the for loop. And we combine it with the image name. The full result would be print full path, and we are getting the right path for every individual image. And that is much more convenient than importing all of them manually. All we have to do now is to import all of this into a surface. And this is going to work like we have done in the Apple. We want to use pygame.image.load. Pygame.image.load. For this one, we don't need the join method because we have the path from the last line. So full path in here, and we are good to go. Also, don't forget, we need convert alpha to convert the data so Pygame can run a bit faster. Finally, I want to have the surface dictionary, and then I want to have a key value pair. The key should be the file name, and the associated value should be the surface. The surface is the easier bit. This we already have. For the file name, I want to have something like, and let me show the folder. At the moment, we have these file names. So what I ultimately want is something like body_bl. And you might be tempted to use the image name, and that'd be a really good idea. The problem with that is that this image name right now would be something like body_bl.png. And we only care about the body.bl. We don't want the .png. So that we have to get rid of, which fortunately is quite easy. All we have to do is to split the string wherever we have a dot. This would give us a list that starts with body and then with png at the end. And from that list, we only want to get the first item. Now, at the end of the function, I want to return the surface dictionary, which is all we need for this method. And just to make sure this is working, let's print self.surfs. And now if I run main.py, we are getting a dictionary that has a key for body.bl and then a surface associated. Next up, we have body.br for bottom right and another surface. With that, we have all of our images inside of one dictionary, and it's really easy to work with them. With that, we can work on draw data, and I think we should keep those two attributes together and call it graphics. And just to be a bit consistent here, let's call the first part setup. Basically, all we want to do is we want to create a tuple inside of draw data for every body part. And in this tuple, we want to have a surface and a rectangle. To make that work, I want to create another method that I will call updateBody. For all of that logic, I'm going to create another method. Let's call it updateBody. No need for custom parameters, and in here, we are going to have quite a bit of logic. First of all, like we have done in the draw method, we have to go through every single point inside of the body of the snake, which is going to be another for loop. For part in self.body. However, that is not going to be enough because we have to know exactly what part of the snake we are on. For example, for the head, we are going to have a different draw logic compared to the rest of the body. Meaning we need to know where we are in the for loop. For example, if we are on the first for loop, we are working with the head. And if we're on the last one, we're working with the tail. And then every other part is going to be the body. This information we are getting via the enumerate method. This one returns the part itself, but before that, it gives us the index of the for loop. Which means what we could, for example, do is print an f string with the index that tells us the index, and then we have the part. This update body we are going to call whenever we are calling the update method all the way at the end. Self.updateBody. This is going to happen regardless of the has eaten attribute, so it has to be outside of the if-else statement. The draw logic should always happen. Let's try all of that, and if I start the game and move, we get the index and then the part. And this happened multiple times, so at the start of the game, index 0 would give us the head of the snake, index 1 would give us the first body part, and finally index 2 would be the tail. Now that we have that, we need to get the position of each of these parts, which means we want to have X, we want to have Y, and from that information, we want to create a rectangle for the positioning. And getting these bits of information is not too difficult. Basically, what we want to do is we want to get the part.x and then multiply it with the cell size. For Y, this would be part.y multiplied with the cell size, and then the rectangle would be a pygame.rect with x, y, and then the cell size and the cell size again. This is basically what we have done with this rectangle down here, except now we are doing it over multiple lines. But otherwise it's the same thing. And after that, we can finally start working on the draw logic. First of all, I want to do the head, which means I want to check if we are on index 0. That would be the head. If that is the case, I want to get self.drawData and then append one value. For now, we can simply pick one of the head bits from the self.serves. If I open it again, we could pick any of these 4 items. I'm going to go with head right, meaning self.serves, and the key is going to be head_right. Besides that, we want to have a rectangle, and all of this needs to be inside of another tuple. Append only wants a single argument, which in our case will be a tuple with a surface and a rectangle. And just to check if this is working, for the draw method, I am going to keep the logic we have so far, although later on we are going to get rid of it. What I rather want to do is for serve and rect in self.drawData. And basically, I want to get self.displaySurface and then split the surface and the rectangle. What this is going to give me, if I run main.py, we have, well, we are splitting the head in the right position. Although you can see there are some minor flaws with all of this. The first issue is that we keep the previous head around, meaning that we are always appending a new head at a certain position, but we never get rid of it. So instead, what I want to do, before we are starting all of this, I want to empty self.drawData, which we can do by assigning it an empty list. If we're doing that, we shouldn't see the head more than once, and that looks pretty good. Cool, that works perfectly well. The next issue then is that the head is always facing to the right, which should make sense. We are only ever using a single surface, the one that's pointing to the right, or whatever you picked, it doesn't really matter. To fix that, I want to create another attribute all the way in the dunder init method, self.headSurface. This by default is going to be self.serves.head_right. However, what we are going to do inside of the update method before we are calling update body, we are going to update this attribute with the correct head position. Let's call this one self.updateHead. This method is going to be fairly simple with self and no custom parameters. First of all, we want to get the head relation. And now we can cover the logic I talked about in the beginning. Basically, imagine that this is the head of the snake and this is the first part of the body. We know that the head is to the right of the first part, and because of that, the actual head of the snake should look something like this. However, if the first part of the body was something like this, then we know the head should be facing down and look more like this. This relationship is what we are getting via the head relation. And doing all of this via vectors is really easy. All we need is self.body and 1, so the first part of the body. And from that, we want to subtract self.body 0. And let's print what we get, head relation. If I now run main.py and press a button, we get -1 because we are moving to the right. To put some actual numbers on this, imagine we have our head again, and the x position of the head is 5, with the next part of the body being in position 4, or column 4 to be a bit more specific. Meaning what we have done with the head relation is body is 4 and the head is 5. The result would be -1. This number means that there's an item to the left of the head, which means the head has to point to the right. With that, all we need are a couple of if statements, and then we are done. If the head relation is equal to pygame.vector2, and for now let's go with -1 and 0. If that is the case, we know that self.headSurface needs to be self.surfs, and the head should be pointing to the right, meaning head right. However, now we can duplicate all of this, and this should be an elif statement. We want to check if this vector is 1 and 0, meaning now we would have something to the right of the head. As a consequence, we should be picking head left. Then we can duplicate all of this again, and now we want to check if there's something on top of the head, meaning -1. If that is the case, the head should be pointing down. Finally, we want to check if there's something below the head, so 1. If that is the case, the head should be pointing up. With that, we have all we need. The final thing, inside of the update method with index 0, we don't want to add the same surface every time. Instead, we want to add self.headSurface. And now for on main.py, we have the head facing in the right direction. So that is feeling really good. Perfect. So with that, we have the head. Next up, we can do the tail, or rather the very last bit of the body. To get that inside of update body, I want to have an elif statement and check if the index is equal to the length of self.body -1. That way we know we are on the last element. If that is the case, we want to do something similar compared to what we have done with the head. In fact, let me copy all of this and change it to tailed surface. And well, for that, first of all, we have to create a tailed surface attribute. Self.tailSurf is going to be, let me copy it. This one should be tail left. Once again, we have the folder and we want to start with tail left. This one seems reasonable. And now that we are adding this body part, it should already be visible. Let's try to run main.py, and once I start, we can see the tail, and everything else works just fine. The tail is always the last part of the body. Cool, this one works. So next up, we have to make sure that the tail is facing in the right direction. This is going to look very similar compared to what we have done with update head. As a matter of fact, I will copy the entire function and change it to update tail. I suppose in there we could also go with tail relation, and now we have to make some minor updates. First of all, we want to look at the relationship between the last item and the item before that in the body of the snake. Which means we want to go from -2 to -1. After we have that, I probably should have just called this the relation, but tail relation works just fine. And, well, this head should also go and should be the tail surface. Oh, also, we have to update the head for all of them. It should always be tail. All right, now we have to figure out the vectors for the relationship. This one is basically the inverse of what we have done for the head. For example, let me draw this actually. Imagine we have the head, then we have the body, and then we have the tail. For the head, we cared that there was an item to the left of the head, or in other words, that the head was to the right of the next element. For the tail, we care about the opposite, namely that the tail is to the left of the next element. For example, what that means, in the tail relation, if this number is 1, we know that there's an item to the right of the tail. And as a consequence, we should be getting tail left. Conversely, if this is -1, then we should have tail right. If there's an item above the tail, it should be tail up. And finally, if there's something below the tail, it should be tail down. After we have that, all we have to do is call self.update tail and then run the game. And now if I try to move around, this is looking perfectly fine. Cool. That means I can minimize both of these methods, and now we can work on all of the other body parts. So else. To cover this bit, we have to know a bit more. Because imagine we just have a couple of body parts. So here is the head, then we have a body part here, 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 and then we have the tail. Imagine we want to place this part of the body. What we have to know is the position of this part and of this part, which we can access because we have the index available. Essentially what I want. Let's call the first bit the last part. This one we are getting with self.body, and then we can use indexing. In my case, I want to look at indexing +1. That way we are getting another item via this for loop. Although I don't really care about the item. Instead, I care about the relationship between these two elements, which means from that bit, I want to subtract the current part. And this I also want to do for, let's call it the next part, for which I can just duplicate all of this. The only difference is that this should be a minus. We don't want to go forward, we want to go backward. The reason why this is useful, for example, if we compare last part.x, and if that is identical to next part.x, if that is the case, I know I have one cell and another cell, and between them I have one part of the snake. I hope that makes sense. Basically, all we are looking at is the last part of the snake and the next part of the snake only on the horizontal axis. And if those two are the same, then we know the current part of the snake must be between them on the vertical axis. What that allows us to do is get self.drawData and append another tuple with self.serves, the key being body underscore horizontal, and the position is the rectangle. Because of that, if I run main.py and I go up, we have the vertical body part. So that part is working totally fine. Besides that, we can now copy all of this and add an elif statement. What we now want to figure out is what happens when both of these are equal on the vertical axis. That case is basically we have one part here and another part here, and both have the same y attribute. The only way this can happen is if we have one item in between. That is this kind of flat item. Which means what we want to place is body vertical. Let's try this one. And now we have a good part of the snake. This is looking really good. And I think at this point, we can get rid of the red background, which we are creating with this for loop inside of the draw method. This I don't want anymore. So now if I run all of this, once you start moving the snake, we have something that doesn't look terribly bad anymore. So we are making certainly progress. The last part we have to figure out are the corners. And this happens inside of an else statement. And let me add a comment, corners. This part is going to be a bit tricky, but if you understand the logic so far, this should be doable. I want you guys to figure out the relationships for the corners. So by the end of this exercise, you should have the entirety of the snake. Pause the video now and try to figure this one out. Let's get started with one example. Say we have one body part here, and then we have one item to the left and one item on top. This could mean two things actually. Number one, it could mean that the snake is going this way. Alternatively, it could also mean that the snake is going this way. We have to account for both options. But ultimately, what we care about is that the top item has a y relationship of -1. So we know that there's something on top. On top of that, we also want to know that on the x-axis, this value would be -1 as well. That way we know there's something to the left of it. Basically, all we have to do is if last part.x is equal to -1 and next part.y is equal to -1 as well. If that is the case, we can get self.drawData and once again append a value. This should be a tuple with self.serves, and the item we are currently looking at is body_TL. Besides that, for the position, we want to have a rectangle. And for reference, body.tl is this file, an upwards curve kind of thing. Cool, this would cover one part. Let's run main.py, and now if I run the game, you can see we have one of the corners. Now, if we are going down, we should have the same corner, which we don't have right now, but we can add that quite easily. So this would be one possibility. But besides that, we also have to add an OR, where last part.y is equal to -1 and next part.x is -1 as well. We essentially flip the direction of these two grid cells, so x and y are inverted, but that's about it. But now we cover both possibilities. So the snake can go this way, and the snake can go this way as well. So this is working just fine. And well, now we have to do 3 more if statements just like that. Let me copy the first one, because all we have to do are some minor updates. First of all, there should be an elif statement. Last part.x can stay -1, but for y, we want to have +1. And I suppose doing this the other way around is a bit easier. The body part we want to place is bottom left, which in the graphics is going to be this part, bottom left. Which means in terms of graphics, the tile we have to place is this, and there's one to the left and to the bottom. As a consequence, on the x-axis, we still want to go one further to the left. But now on the vertical axis, we care about an item being below it, which means next part.y should be 1. This part is +1. And this once again can also go the other way around. Meaning that if I clean this one up a tiny bit, this current statement means that we have one part going here, then covering our current part, and then going down. What is equally possible is that an item first comes from the bottom, then passes through our current tile, and then goes left. This we also have to account for, which we can do quite easily. We want to check if last part.y is 1 and next part.x should still be -1. With that, we have all we need. If I now run main.py, and the snake has one more corner. So that is starting to come together quite well. After that, I can duplicate all of this one more time. Now we want to place body, and let's go with top right. Once again, in the graphics, what we are placing is this part, where we care about a tile on top and to the right. This one is basically the inverse of body bottom left, meaning we simply have to invert all the ones and -1s, and then we should have the proper result for this. And I know this video got a bit longer, so I'm going to speed up just a bit, but we are nearly done. So these corners still look totally fine, which means we just have one last case where we want to check the bottom right. And this happens when we have 1 for all of these cases. This is actually one of the easier ones. And now, if I run main.py, we should have all of the corners. And this is looking pretty good. Cool. This is a massive upgrade to the game, and I am very happy with that. And yeah, I can't see any errors. Oh, actually there's one problem. If we now crash into something, the game needs to update one more time to once again show the starting graphic. That we can do inside of the snake. We can minimize this method and work in the reset method. After the snake restarts, we also want to reset the graphics, which we're doing with self.updateHead, self.updateTail, and self.updateBody. So the basic issue is right now, after the game crashes, we stop calling the update method, this one here. And because of that, we stop updating the graphic and keep the last bit of graphic when the game crashed. which isn't accurate anymore. We want to do this one more time, so we are showing the starting position, which is what we are doing with these couple of lines. So now if I run main.py again, I can crash, and now we have the proper starting position. Although I also realized when we just start the game, we can't see anything, because by default, this update method needs to run once to display the snake, which we can also do when we are calling the dunder_init method. All we have to do is call self.updateBody, and with that, we are getting the starting position of the snake. And that covers the entire drawing logic of the snake, and that looks really good. Perfect. And well, this became a slightly larger video. We have covered a lot of logic for this game, so I hope you could follow along.